let's look at some examples where the input, instead of being some angle with like a regular value, is some algebraic expression. So our goal is to then write each expression in terms of u, but without the trigonometric functions attached. So example, write each expression in terms of u. So I'm starting here with my inside, which is arc sine of the quantity 3u over 5. And I am going to say that, so kind of my first piece is arc sine of 3u over 5 is some angle, and I know that angle has to be in between negative pi over 2 to pi over 2. Okay, so let's draw that. And where would that live? Well, negative pi over 2 to pi over 2, okay? And then I can assume, okay, so I can first write sine of theta is then equal to 3u over 5. And I can assume that 3u and 5 and all parts of that are all positive. So I'm going to put theta here in quadrant 1. So I'm more specific than just the range of arc sine. I know which quadrant I'm in. So I just draw that kind of anywhere. So here's my angle, here's my angle, theta. Got a little ahead of myself here. And there are kind of three key pieces here. R is going to be the length of the radius of the circle, and again, not necessarily on the unit circle. And then I have some point xy where the terminal side of my angle intersects the circle. And so I know that according to my trigonometry, where I'm defining not on a unit circle, that sine of theta is equal to y over r. So 3u will be my y and 5 will be my r. So then I can construct a right triangle and use Pythagorean theorem to solve for my missing value. In this case is x. So I have right triangle. R is just r. So it is the hypotenuse of my right triangle. But I said, that's equal to 5. So let's do that. 3u is y. Well, guess what? I know that to go to that point, I'm going to go over x up y. So 3u is going to be the vertical length of my triangle there, that leg. And then I need to have x down here for the horizontal leg, and I'm going to solve for x. So I have x squared plus 3u squared equals 5 squared according to my Pythagorean theorem. Solving for x just means in terms of u and other things. So I'm going to have x squared equals 25 minus 9u squared. So x is the square root of 25 minus 9u squared. And because I'm in quadrant 1, I'm using a positive x value. Okay, so I have x now. Okay, so let's go find everything, make sure I have it. I have r is 5, y is 3u, and x is this big thing here. So now when I go to actually complete this, I'm going to have, cotan, start there. I'm going to rewrite my entire expression. Cotan of arc sine of the quantity 3u over 5. That's going to be equal to the cotan of theta, because I already defined arc sine of 3u over 5 to equal theta. So I just replace arc sine of 3 over 5 with theta. Now I have cotan of theta. So this is where I have to remember my definition. Cotan of theta is at this angle, x over y. And again, I'm still at that same angle, so I can still use the same x, y, and r. So what's x? X is the square root of 25 minus 9u squared, and y is just 3u. Now I'm done. No simplifying needed. Let's go to the next one. Part B, tan of cosine inverse of the quantity u over the square root of u squared plus 9. So cosine inverse of u over square root of u squared plus 9. That's going to equal to some angle. And because this is an output of cosine inverse, I know that angle has to be within 0 to pi. So I can draw it, a circle, and I'm just pointing out where 0 to pi is. Okay, now I know more than that, because then I can write cosine of this angle theta is equal to u over square root of u squared plus 9. Now again, I'm assuming that u is positive and everything is groovy, because why not? And so, do that, no, that means that I'm going to be in quadrant 1. So here's my angle theta. Now let's define x, y, and r. So here's the point xy, and the length r is just the length of the radius. Okay, So what do I know? Well, cosine of theta is equal to x over r. So now I need to solve for y. So in order to solve for y, I just construct a right triangle. And the right triangle is going to fit just nicely in there. So you can draw it in there, but it's usually not quite enough room to solve. So I just draw another one down here. R, oh, I do know r. So I'm just going to write it in. Square root of u squared plus 9. This is a right triangle, and again, this angle is theta. I know x is u, and I'm going to solve for y, and that's just going to represent the vertical length of this triangle. All right, so I'm going to have u squared plus y squared is the square root of u squared plus 9. It's easy to get a little disoriented here because there's a lot of variables, but again, I'm trying to isolate y. So I have y squared, and oops, let me go back one here. For Pythagorean theorem, I need to square everything. So u squared plus y squared plus the square root of u squared plus 9, all squared. So I get y squared equals u squared plus 9, and then take away the u squared from the other side. I get y squared equals 9. So y is plus or minus 3, but since I'm in quadrant 1, I have y equals positive 3. All right, so now I go track down everything. Did I get it all? Let's see. I have x is represented by u, r is represented by the square root of u squared plus 9, and y is represented by 3. So now I just go ahead and write everything all together. So starting from the beginning, tan of cosine inverse of the quantity u over the square root of u squared plus 9. I'm going to say that is equal to just the tan of theta, right? I said this whole thing I'm just saying is equal to some angle. And then what is the tan of that theta? Well, according to trigonometry on a circle, not necessarily the unit circle, is tangent is y over x, y is 3, and x is